Hello, you zero-point energy researchers out there. This is a little update on what the inside of one of these zero-point energy batteries looks like. Currently, this other one I made is drawing at about 0.723 volts. And once again, it's just sitting inside a copper pipe right here, which is empty. As you can see, there's nothing in here. The copper pipe is pretty much empty as you can get it. And most of the pyrite on this is on the inside, touching the magnesium core. But as you can see, once again, 0 volts, and it goes inside the copper cap. You get a huge amount of voltage. So basically, once again, what's happening is the energy field is being activated by the copper. My leads were touching here. That's probably why the voltage went a bit funny. But bring my leads over here so they don't end up touching each other again. Remember, it's just a rough circuit. Right now, this circuit's drawing about 0.80 volts. And once again, as you can see, when I take it out of the copper cap, the voltage goes to 0. Put it back in the copper cap, it goes back up again. So anyway, basically what the inside of one of these looks like, I got the magnesium core right here, and then I have the, I basically use a hand-wiped paper towel or any sort of cotton, anything that contains cellulose, like a cellulose fiber. Basically, I just wrap it around the magnesium, but I make sure that I have pyrite and some galena mixed in with the paper towel. Wrap that around the magnesium, apply sodium silicate, let it dry for a few days, and it comes out like this. There's a little bit of pyrite on the outside right here, but most of the pyrite is on the inside napkin here, touching the magnesium. But as you can see, if I can get a close-up right here, so you guys can see it, if I can get a zoom in here or something. Basically, this is about 2 or 3 turns of the fiber paper. And as you can see, the magnesium hasn't even been saturated by it. But there's no corrosion, no major corrosion up here. Corrosion occurs over time, but very, very slowly. But it's a very simple design. I'm working on increasing the voltage. And this one, like I said, hasn't even been soaked or hasn't even been put in activated carbon. It's just been soaked with the sodium silicate, with the fiber, paper towel, etc., etc. So it gives a pretty hard surface. It's stable, and it still gives a pretty good amount of current. Once again, as you can see, it's a nice, soft cellulose. As long as the fiber contains a cellulose fiber, that's what reacts to the sodium silicate to give a pretty good voltage. See if I can zoom it in here so you guys can get a closer look right here. Let me see here. Yeah, it's pretty simple setup. Once again, 0 volts. Put it in the copper cap, and we go up to about. She climbs up to about 0.80 eventually over time. But this is the common steady voltage. As long as it stays in the copper cap right there, they get a steady, common, constant voltage. So remember, this is just a rough setup. It's nothing permanent. It's just these are basically prototypes. But the good news about this is that I don't need to apply water. Water basically will cause corrosion over time. It can also be a little bit messy. Basically, by not applying water, it also preserves the battery a lot longer. And also by not using a lot of activated carbon or sand or basically desiccates in here, we can keep this pretty much empty. As you can see, there's nothing in here. It's totally empty. Just a little bit of stuff in there. Just left over from this stuff right here. But this is basically a dry cell. The best part about this, once again, no voltage. Put it in the copper cap. And we're currently drawing about just a little bit over half a volt. And that's pretty cool. So thank you for watching, and have a great day. This is Easy 3D Biz coming to you live from beautiful Southern California, and wishing you all a great day. Bye-bye.